The summBg function is for summarizing biogas data. Probably the most typical application is in calculating biochemical methane potential, or BMP. Let's load the biogas package, load some example data sets, and we're going to use vol and comp, which were described in a video for summBg. We're going to use vol and comp to calculate cumulative biogas production with the summBg function. I'm not going to describe this function in any detail. Take a look at the video for summBg to get more info on it. Okay, so now we're going to work with cumulative biogas production data and this other data frame setup, which as a minimum has to contain one row for each reactor in our other data frame with the cumulative volumes, and then just some kind of a description of that reactor. So these can be grouped together. So reactors 2.1, 2.2, and 2.3 all had substrate A in them. The last three reactors, it looks like they all had just an inoculum in them. Okay, so in its simplest usage, summBg can be used to summarize cumulative production data. So it does two things. It interpolates cumulative production to a specified value for all individual reactors, and then calculates means and standard deviations for each reactor. So here we're going to go to 60 days, and we need to specify the name of the time column. So it's days here. So here's our mean for A is 2200, and then we have higher means for the inoculum only and substrate B. This is milliliters per reactor. We have a standard deviation and then an N of 3 for each of these. And pay attention to these messages here. They might help you avoid mistakes. They tell you that what the response variable is, that the inoculum contribution has not been subtracted, and that there was no normalization. Well, let's subtract the inoculum contribution and also perform a normalization. So to subtract the inoculum contribution, we need to specify something for the inoc.name argument. So what we should be referring to here, what we need to refer to is a column within the setup data frame, or rather a value within the descript column here. So inoc.name is inoc, and this is going to be used to identify those reactors that contain inoculum only. So here the inoculum contribution was subtracted out. There's still no normalization by substrate mass. If we want to normalize that by substrate mass, we need to work with the norm.name column. And here we're going to refer to M sub. This is the column in this data frame that has the mass of substrate. And of course any units could be used. In this example data set, the units are grams of substrate VS, grams of substrate volatile solids, within each reactor. So M sub is what we want here. And now what we've done is we've calculated BMP for these substrates. So substrate A has a BMP of 181 and B has a BMP of 154. We can see data for individual reactors using the show.ops argument. Set it to true. Now we have data for individual reactors as well as the calculated contributions of inoculum and by difference substrate. And it's also possible to use multiple times here. If we want day 10, day 60, and day 100, for example. So compare this to this. Here we have just day 60, and here 10, 60, and 100. If we take a look at CVG, By default, the summBg function is going to use this column, CVCH4, but we could have it use any column if we wanted to summarize the rate of, well, the rate of methane production instead of cumulative methane production, for example. Let's do that by saying vol.name equals RVCH4. So now our response column is RVCH4, and we've just calculated the normalized rate of methane production. Now, it may not make sense to try to normalize that for a particular point in time, so let's just look at the actual rate at a particular time. Well, there are the mean rates, milliliters per day, because cumulative production is in milliliters. Our rates are milliliters per day, also because our time is in days. So the vol, comp, and setup example data sets are pretty easy to work with because the names of the important columns match default values for arguments in summBg and also cumbg. Let's look at an example where that's not the case. So I described the vol2 and comp2 data frames in the video for cumbg, and I also used them to calculate cumulative biogas production. So I'm not going to repeat that. I still have that CBG2 data frame here. And there it is. But let's take a look at setup. So CBG2 has cumulative biogas production based on vol2 and comp2. Setup is the wrong one. I want setup 2. Setup 2 has a description of each of the 15 reactors in this data set. In this case, the descriptions are relatively clear, as well as the mass of substrate Vs in each reactor, and then the mass of inoculum. Okay, so let's use summBg to calculate BMP here. CBG2, setup is setup 2. When, we'll do 60 days again. ID.name is bottle here. You can see bottle in those two data frames I have up above. Time.name is days. To script.name, we didn't use this one before because the default value worked well, but here it doesn't. Script.name is now description. That's the name of the column in setup that has a description of each reactor. And let's see, we need also inoc.name. That is inoculum with a capital I. And we need inoc.m.name. That's inoc.mass, all lowercase. And do we need anything else? Yes, what do we want to normalize by? By sub.vs. That's norm.name. Okay, let's see if that works. It seems to. The response variable is CVCH4, that's correct. Inoculum contribution is subtracted out based on inoc.mass, is that right? Sorry, I'm going to resubmit this. I keep calling up the wrong setup data frame. Okay, it's based on inoc.mass, that's correct. And normalization is by sub.vs. That looks correct as well. So here are our BMP values, standard deviation, and number of samples. Well, we could use predBg to see how realistic this cellulose value is. C6H10O5 for cellulose. And the theoretical BMP is around 414 milliliters of methane. And here in this data set, the mean is 453. So it looks a little high, but not bad, maybe 10%. 10% is not bad in biomass research. Of course, some of this substrate should be going to microbial biomass production. So it is somewhat worse than 10%, maybe around 15 or 20.